Stan Gibilisco here to talk about the concept of antenna traps and how you can use them in a dipole antenna to get multi-band operation. What I'm showing here is a half wavelength dipole fed in the center, a 1-to-1 balun transformer makes sure that the coaxial cable will behave itself with respect to this antenna, and also to make sure that the feed line will behave itself, you should run it away from the antenna at a 90-degree angle for at least a quarter of a wavelength on the lowest frequency that you intend to use the antenna. Now let's suppose that we have this antenna cut for 40 meters, let's say. If it's cut for 40 meters, then it's going to be 1/2 wavelength at 7 megahertz electrically, which is approximately 66 feet or 20 meters from end to end, fed in the exact center. Now let's suppose that we want to work this antenna on 20, 40, and also 10 meters, let's just say. So we want to have, well no, let's say 20, 40, 15, and 10 meters. 20, 40, 20, 15, and 10 meters. Well, we can feed this thing with open wire line, get rid of the balun, and use a transmatch at the radio. That's one way to do it, and that's actually the way that I would prefer to do it. However, if you want to use coaxial cable as your feed line, or if you're forced to, you have to run it down some kind of a metal mast or something like that where open wire just won't work very well. You can add traps to a dipole of a specific predetermined length, and you're not going to really know what that predetermined length is. Do you believe in predestination? I do, but I don't believe there's any way for us to know our destiny. So for all intents and purposes, you're just going to have to start from scratch, okay? So let's suppose you want this thing to be resonant on 10 meters. You put a 10-meter trap right here and right here, such that you end up with a 1/2 wavelength dipole antenna for 10 meters stopped by these traps at either end. Now there's a couple of caveats with respect to all traps in dipole antennas like this. First of all, they all have to be spaced precisely the same way on the right-hand side of the antenna as on the left-hand side. That is to say, if you take any pair of traps for a particular band, the feed point always has to be exactly midway between them. That's caveat number 1. Caveat number 2 is that when you tune these traps, you should tune them for precisely the same frequency within the band. So for example, if you wanted to tune this at 28.1 megahertz, if this one's tuned for 28.100 megahertz, then so should that one be tuned for 28.100 megahertz. Not only that, but the inductance and capacitance values themselves should be identical. So these two traps should be exact duplicates, clones of each other. The two sides of the dipole as well, clones of each other. Now, with this arrangement, if you make these sections of the correct length, you can get resonance on any one of these other bands, depending upon how long these lengths are, and you'd have to figure that out by experimentation. But now, let's suppose, okay, these are the 10-meter traps right here. Suppose that you put now a pair of 15-meter traps at just the right lengths from the center, so as to produce a half-wave dipole on 15 meters. Now it's going to be a little shorter than a true 15-meter half-wave dipole would be because of the loading coil effects of these 10-meter traps. However, these are the 15-meter traps. Now this thing will work on 10 meters, 15 meters, and any other band below 15 meters of your choice, depending upon how long you make these remaining sections. Well, let's add a 20-meter trap here, a 20-meter trap here. So that now we have a 10, 15, and 20-meter triple bander plus a fourth band, another band that we can determine according to how long these outer sections are, and let's suppose we want to make that 40 meters. So 40 meters, the entire antenna will radiate, but it will be shorter than this 66 feet or 20 meters because of the distributed loading effects of these inductors within these traps at that frequency. They won't act as traps at that frequency, remember. They'll act like loading inductors. Now, then again, the 20 meters between these two traps right here. 15 meters between these two traps. 10 meters between those two traps. And you might just get lucky and find that this whole assembly resonates on some frequency that you never would have imagined. And if that frequency happens to be one of the ham bands, well, lucky you, okay? Sometimes that does happen with multi-band antennas, but not very often. So with that, I will just remember now that the right-hand side and the left-hand side of this antenna should be precise clones of each other in every technical respect. Just exactly as if you had duplicated one with a matter duplicating machine from Star Trek some unknown generation. Well, maybe you could print it on your 3D printer. You print a dipole on your 3D printer. How about you print a house? How about you print, like, say, a mountain? How about you print a whole planet? And finally, how about you print a person? Oh my God. I'm getting really weird today, aren't I? But this is the trap dipole concept. Stan Gibilisco, W1GV, Whiskey 1, good vibrations. Signing off, saying 73 for now, and so long.